All right, sample problem 4.17 deals with oxidation numbers. It says determine the oxidation number of each element in these species, and the first one listed there is zinc chloride. And remember, our first step, whenever we have the name of a compound, is to write the formula. So zinc has a 2+ charge, so zinc, and then chlorine has a -1 charge, so it's going to be zinc chloride. Zinc and 2 chlorines to cancel out that +2 charge. All right, the next step, now we have to determine the oxidation numbers. And what am I talking about when I say oxidation numbers? Let me pull this table up for us here. Table 4.4 from the textbook. This is on page 170. Or I pulled this directly from the slides, as you can see here, the class notes. I have all these rules. And it says the general rules. Number 1, for an atom in its elemental form, the oxidation number is equal to 0. Number 2, for a monatomic ion, the oxidation number is equal to the ion charge. And number 3, the sum of oxidation values for the atoms in a compound equals 0. The sum of oxidation values for the atoms in a polyatomic ion equals the ion charge. All right, and then we have all these rules for specific atoms on the periodic table. And I'm not going to go through all of those, but we're going to use one of them here immediately, right? I'm looking here, and I have zinc and I have chloride ions. Now, I don't have any general rules for zinc chloride up here. This is a compound. This is a ionic compound. And I don't have any rules for ionic compounds. But I do have a rule for group 7A that are combined with metals, right? Chlorine is a halogen. That's group 7A. Zinc is a metal. It says, for group 7A, the oxidation number is equal to -1 in combination with metals. So I'm going to write in red here a -1 above that chlorine. Okay? That means that it has an oxidation number of -1. I do not have a rule for zinc, so how the heck am I going to figure this out? If you notice, general rule number 3, the sum of oxidation values for the atoms in a compound equals 0. So if I add up the oxidation numbers for the chlorine and the zinc, they're supposed to equal 0. So if this is -1, and I've got 2 of them, 2 times -1 is -2. I have to ask myself, what plus -2 equals 0? The only answer there is +2, right? +2. So the oxidation number for zinc is +2. So that they can add to equal 0. Now let me move that out of the way so we can look at sulfur trioxide. So B, I've got to write a formula for sulfur trioxide. Sulfur is just S, right? Has a 2- charge. Well, this is a covalent compound, so I don't have to worry about charges here. I can just use the name, 1 sulfur, 3 oxygens, SO3. Right? And that is going to be an example of, like I said, a covalent compound. Easy. Those are easy to write the things for. So let's see. What rules do I have? I've got to assign oxidation numbers for this thing. I don't see anything about sulfur on here. What about oxygen? There we go. For oxygen, it says the oxidation number is equal to -1 in peroxides or -2 for all of the compounds except for with fluorine. I don't have a peroxide here, right? This is not H2O2. So what that means then is that the charge must be -2. I mean, not the charge, sorry, the oxidation number. So I'm going to write that up here, -2. And so now I have no rules for sulfur, but remember this general rule here. It says the sum of the oxidation values must equal 0. So if I have 3 of these -2 oxidation numbers, 3 times -2, that's -6. Let me write that down here. So I've got -6. So I've got to ask myself, what plus -6 equals 0? What's x have to equal? X must have to equal +6. So that means that the oxidation number for sulfur is +6 here in this example. Now let's see, what is C? I have nitric acid, C part. HNO3. All right, so we got 3 things here that we have to assign oxidation numbers for. So let me check my rules. All right, do I have a rule? I just remembered a rule for oxygen. Remember, we just looked at that one. We also have a rule for hydrogen. We don't have one for nitrogen, though, but that's okay. Maybe we can figure it out using our general rule number 3 and the sum of those things being 0. So for oxygen, it's going to be -2, right, because this is not peroxide and this is not fluorine. So let me put my -2 above -2. All right, and then for hydrogens, it says that my rule is +1 in combination with nonmetals and -1 in combination with metals. Nitrogen and oxygen, neither one of those things are metals. So it must have to be +1. So let me put a +1 up there. So now let me tally things up. I've got for oxygen. Let me get this here. 3 times -2 equals -6. All right, and then I have 1 times +1 for the hydrogen. That equals 1. Let me get some room here. And now let me add those two things together. That's going to equal -5. Okay, so for nitrogen, then what does nitrogen have to be? -5 plus x, some number, must equal 0. The only thing that makes that true is if x is +5. So let me put my +5 above my nitrogen there, and that's the oxidation number of nitrogen.